These examples go with Lesson 8.2, Hypothesis Test for a Population Mean, Standard Deviation Known. This is part 1 of 4. Example 1. A test is made of the null hypothesis mu is equal to 25 versus the alternate hypothesis mu is less than 25. The value of the test statistic z, or is z is equal to negative 1.84. We are going to find the critical value and the critical region for a significance level of alpha equals 0.05. Okay, let's draw a picture of what's going on here. We have a left-tailed test, and I know that because of the less than sign right here. And so in our picture, if we sketch in our normal curve, the left-tailed test is going to go from the left side, from somewhere in here, and we're going to shade it to the left. Now, we are looking for the place where the area is actually equal to 0.05. So I'm trying to figure out what this number is right here, and it will be a z-score, so that the area in here is going to be 0.05. Now, fortunately, I can pull that off of table A3 down on the z-line. So when I'm looking down here on the z-line of table A3, I notice all I have is percents, and they gave me an alpha level of 0.05. Well, if we take and we look at higher up on the chart, we'll notice that we have the areas in the right tail here, and 0.05 is right here. So this is going to be my alpha level. And this is going to be, let's see, 1, 2, 3. This is the fourth column over. So what I'm going to do is I'm going to be in the column 0.05, and I'm going to go all the way down to the z-line to get my critical value. So 1, 2, 3, 4. My critical value right here is going to be 1.645. And we know we want this number to be negative, and the reason that I know we want it to be negative is because, well, my test statistic here is negative 1.84. So because of symmetry on my normal curve, if I know there's a point out here, positive 1.6445, so that the area over here is 0.05, I know that there is a corresponding point back here, negative 1.645, so that the area is 0.05 to the left of it. All right, so now we have found the critical region. Here it is. It's shaded in. We have found the critical value. That's going to be negative 1.645. And now we have to decide in part B, do we reject the null hypothesis at the alpha equals 0.05 level? Well, that depends. Where is my critical value according to my picture? I'm sorry, my z-value. If the critical value occurs right here at negative 1.645, where does 1.84 or negative 1.84 go? Is it going to be to the right of negative 1.645? Is it going to be to the left of negative 1.645? Or is it the same as negative 1.645? And I hope we can all agree that negative 1.84 is actually going to be further back here to the left and inside this blue region. So whenever our z statistic is less than our critical value, then we are going to reject the null hypothesis. We will reject the null hypothesis because our z statistic, negative 1.84, is less than our critical value, negative 1.645. All right, let's look at part C. Now we're going to find the critical value in the critical region when the significance level is 0.01. Let's change colors right here. Let's go with plum. Okay. We'll sketch in our normal curve. And what I am looking for is I'm looking for this number right here, so that all of the area right here is 0.01. And I'm going to pull up table A3 again, and I'm going to have to go up to the top here. Let's see, 0.01 is an alpha value that's right here. This occurs 1, 2, 3, 4, 5 columns from the right. Now I'm going to go all the way down to the Z line. And we're going to go 1, 2, 3, 4, 5 columns from the right. That gives me my critical value, 2.326. And remember, we're going to make that into a negative 2.326 because we knew we had a test statistic of negative 1.84. And now we're going to try and decide whether or not to reject. Now, the best thing to do is, does my test statistic fall in the purple region or in the white region? If it's in the shaded purple region, we're going to reject. If it's in the unshaded white region, we're not going to reject. I think I'm just going to put the mean right here of 0. All right, let's change colors. Where does negative 1.84 fall down here on my horizontal axis? Is negative 1.84 to the left of negative 2.36, or is it to the right of negative 2.36? I hope we can agree that negative 1.84 is going to be somewhere here, less than 0, but more than negative 2.36. And y'all, since negative 1.84 is in the white unshaded area, we will not reject the null hypothesis. Because our test statistic, negative 1.84, is actually greater than our critical value of negative 2.326. Example 2. A test is made of the null hypothesis mu is equal to 7.5 versus the alternate hypothesis mu is greater than 7.5. The value of the test statistic is 2.71. For part A, we're going to find the critical value and the critical region for a significance level of alpha equals 0.05. Let's draw a picture of what's going on here first of all. We sketch in our normal curve. We're trying to find this number right here so that, nope, not that one, sorry. We're trying to find this number here so that the area to the right of it, and I know I want the area to the right because I have a right-tailed test here. We want this to be 0.05. All right, let's go to table A3. We want 0.05, 1, 2, 3. This is the fourth column over. We're going to go all the way down to the Z line. And there it is, our critical value, 1.645. And we will be using the positive value of 1.645 this time. And I know this because we have a right-tailed test here. All right, so we are going to use 1.645. That's our critical value. For part B, are we going to reject the null hypothesis? Well, that depends. Where is the test statistic located? In my picture, 2.71, is it over here in the white region? Is it less than 1.645? Or is it over here in the blue shaded region? Is it more than 1.645? And we can see that it's going to fall somewhere back here, which is in the shaded region, or the blue shaded region there, because 2.71 is actually greater than 1.645. So yeah, we are going to reject the null hypothesis. All right, so for part B, we're going to reject the null hypothesis because our test statistic, 2.71, is greater than the critical value we found, 1.645. All right, part C. Now we want to find the critical value in the critical region when alpha is equal to 0.01. So once again, I'm going to sketch in my normal curve, and I am looking for this number right here so that we're doing a right-tailed test, and I want this area to be 0.01. We'll pull up table A3. 0.01, 1, 2, 3, 4, 5, all the way down to the Z line. 1, 2, 3, 4, 5. This is 2.326 for my critical value. Okay, let's sketch that in. So part C, the critical value is 2.326. And then for part D, now, are we going to reject the null hypothesis or not? Well, let's see. Where is 2.71? Is it going to be back here in the white unshaded region because it's less than 2.326? Or will it be over here in the purple shaded region because it's greater than 2.326? It should be back here, just barely more than, but still more than. And since it falls in the purple shaded area, we are once again going to reject the null hypothesis. And we're going to do that because our test statistic, which measures 2.71, is greater than our critical value, which we found to be 2.326. Example 3. A test is made of the null hypothesis mu is equal to 12 versus the alternate hypothesis mu is not equal to 12. The value of the test statistic is z is equal to 1.78. We're going to find the critical value and the critical region for a significance level of 0.05. Now this one is a two-tailed test. And so when we draw a picture and sketch our normal curve, we're looking for two values. We want one here, and we want one here. I'm just going to put a negative on here because remember we have symmetry, so whatever this one is, this is the opposite of it. And I want this so that the two areas here add together and give me 0.05. And because of symmetry, that means I'm going to be putting 0.025 over here and the other 0.025 over here. Now, where did that come from? That came from the fact that 0.025 plus 0.025 is equal to 0.05, which in this case is my alpha level. Because it's a two-tailed test, I had to take my alpha level and split it into two parts and put half of it on the right and half of it on the left. Now when I go to find my critical value, it's not going to be for 0.05, it's going to be for 0.025. So let's pull up table A3. 0.025 right here in the middle. 1, 2, 3, 4. That's the fifth one from the left. Let's go down to the Z line. 1, 2, 3, 4, 5. Right here it is. 1.960, that's going to be my critical value. And I know, because of symmetry, if this side is 1.96, then this one back here is going to be the opposite of that, or negative 1.96. So my critical values, 1.96 and negative 1.96. Are we going to reject our null hypothesis at the 0.05 level? Well, the rules are going to be the same here. So if my z statistic falls inside either one of my purple regions, or my blue regions here, then yes, I'm going to reject it. But if it falls in the white unshaded region, then no, I'm not going to. 1.78, okay, that's going to be definitely to the right of negative 1.96 because it's greater than. And in fact, if we put the mean 0 right here in the middle, it's going to be right here, more than 0. 1.9, well, I think 1.78 should be about right in here. It's going to be more than 0, but it's going to be less than the 1.96. Now, because it falls in the white shaded region, we are not going to reject. Do not reject the null hypothesis because the test statistic 1.78 is actually less than our critical value 1.96. All right, let's take a look at part C. We're supposed to find the critical value and the critical region when the significance level is 0.01. Let's draw a picture of this. We'll sketch in the normal curve right here. I am looking for this value right here and this value right here, so that when I add these two areas together, it's going to give me 0.01. And that means each side is going to have to be 0.005. And again, we're splitting this alpha value in half because this is a two-tailed test. If this is a greater than, we have a right-tailed test, don't do this. If this is a less than, we have a left-tailed test, don't do this. But because it's not equal to, it's a two-tailed test, we're going to have to put some of that area over here on the right and some of it over here on the left. And again, it came from the fact because I know that 0.005 plus 0.005 is going to give me 0.01, which was my alpha value right here. All right, let's pull up table A3. We are looking for 0.005. That's right here. This is the 1, 2, 3, the fourth column from the right. That's going to give me 2.576 as a critical value. This side will be 2.576, which means that by the magic of symmetry, this one over here is going to have to be negative 2.576. And that is this point here and this point here. Now we want to figure out where my z statistic is. We got positive 1.78. Well, if the mean is right here, 1.78 is going to be to the right of that, but it's not going to be near as far as 2.5. It should be somewhere in this area right here. So once again, because 1.78 is located in the white unshaded region, we are not going to reject the null hypothesis. Do not reject the null hypothesis because the test statistic 1.78 is less than our critical value, 2.576. And I forgot to write these in here. We had negative 2.576, and then the other one was going to be at positive 2.576. Example 4. A test is made up of the null hypothesis mu is equal to 15 versus the alternate hypothesis mu is greater than 15. The sample mean is x bar is equal to 16.5. The sample size is n equals 50, and the population standard deviation is sigma is equal to 5. The first thing we want to do is find the value of the test statistic. And we have a formula for the test statistic, and it is right here. We're supposed to take the sample mean and subtract mu 0. We can find that in the null hypothesis. And then we're going to divide it by the standard deviation divided by the square root of the sample size. Our test statistic is called Z, and we're going to take the sample mean and subtract the mu 0, which we can find right here in the null hypothesis. There it is, it's 15. And we are going to divide that by the standard deviation, which they gave me to be 5, divided by the square root of the sample size, which they gave me to be 50. And I will put this in my calculator and see what I get. This gives me 2.121. So there's our test statistic. All right, now B, we're looking for the critical region and for level alpha equals 0.05 test. Now we have a right-tailed test. So if we draw a sketch of our normal curve, we're looking for the number right here so that the area to the right, remember this is a right-tailed test, is equal to 0.05. And I'm going to pull up table A3 and find out what this one is, what this value is. 0.05. This is the fourth column over. We're going to go down to the Z line. This is 1.645. Take that away. This value is 1.645. And now we have to decide if we're going to reject the null hypothesis or not at the 0.05 level. Well, let's look at our test statistic. Where is 2.121 located? Is it over here in the green area because it's more than 1.645? Or is it back here in the white area because it's less than 1.645? Our Z statistic is going to be over here in the green shaded area because it is more than 1.645. And remember, when our Z statistic falls in our shaded area, that's when we're going to reject the null hypothesis. So reject the null hypothesis because our Z statistic, 2.121, is greater than 1.645. Example 5. A test is made of the null hypothesis mu is equal to 125 versus the alternate hypothesis mu is less than 125. The sample mean is x bar is equal to 123, the sample size is 100, and the population standard deviation is sigma equals 20. Part A, we want to find the value of the test statistic Z. All right, let's see. Z, our test statistic, is going to be our sample mean, here it is, 123, minus mu 0. We can find that right here in our null hypothesis. That's going to be 125. divided by sigma, which they gave me to be 20, divided by the square root of the sample size, which they told me is 100. All right, let's put this in the calculator and see what we get. And this gives me -1, and that came out really nice with no kind of decimals or anything in there. Okay, B, asking us to find the critical region for an alpha level of 0.02. Now, this time we're doing a left-tailed test. So if we draw a picture of this, left-tailed means I'm looking for this number right here so that the area to the left of it is 0.02. And I can find this on the Z line from table A3. So let's pull up table A3. 0.02 Okay, so you'll notice down here along the Z line on the bottom, we didn't have a 0.02. Sorry, it wasn't on the bottom line. It was up here on the top row. We don't have a 0.02. We have a 0.025, but we don't have a 0.02. So when that happens, we're allowed to pull up table A2. And what we're going to have to do is we're going to have to do a reverse lookup. And what that means is I'm going to be looking in the body of the table here for 0.02 or 0.0200 or as close as I can get to it. And then I'm going to read off to the side and figure out what the z-score that goes with it. Now, in my picture, I'm doing a left-tailed test. So that means I'm going to want to have a negative z-score. So I'm going to stay in the negative z-scores here. And remember, I want to have 0.02. Now, this is 0.0002. So I'm going to keep going on down. This is 0.001, 0.01, 0.017, 0.0228. So here we go. We're getting into the right place. This is a little bit too much. So we'll read down here. I notice the numbers are getting smaller, 0.0222, 0.0217. Remember, I want to get as close to 0.0200 as I can. 0.0212, 0.0207, really close, 0.0202, and then 0.0197. It looks like my best bet is going to be the 0.0202. And the z-score that goes with that, we read over here to the left, is negative 2.0. And then we read up 5. So negative 2.05 is going to be the test statistic, not the test statistic, but the critical value that we want, negative 2.05. That's going to be our critical value there. All right, now, part C. Are we going to reject or are we not? Let's find out. Our test statistic was -1. Our critical value is negative 2.05. So the question becomes, is -1 less than negative 2.05 and over here in the orange area, or is it more than negative 2.05 and over here in the white area? And I think we can agree that -1 should be somewhere back here, you know, less than 0, but more than negative 2.05. And when our test statistic falls in the white unshaded region, remember, we do not reject the null hypothesis. And the reason we're not going to reject the null hypothesis is because my test statistic of -1 is greater than my critical value of negative 2.05. So our lesson learned here, y'all, is that it's probably easiest to pull the critical value off of table A3, but if it's not there, you can go over into table A2 and get it. Example 6, a test is made of the null hypothesis mu is equal to 100 versus the alternate hypothesis mu is not equal to 100. The sample mean x bar is equal to 97, the sample size n is equal to 75, and the population standard deviation is sigma equals 8. We are going to find the value of the test statistic z for part A. Our z formula is the sample mean 97 minus mu 0, which we can find right here in the null hypothesis. This is going to be divided by the standard deviation sigma, which they told me to be 8, divided by the square root of n, which they told me to be 75. So let's put this in the calculator and see what we get. This is giving me negative 3.248. Now we want to find the critical region for a level alpha is equal to 0.01 test. Now, we have a two-tailed test here, which means we're going to have to take the alpha and put half of it on the left side of my curve and half of it on the right side of the curve. So let's take a look at this. If we sketch in our normal curve, we need to know this value here and this value here, so that these two shaded areas add together and give me 0.01. That means part of the area over here is going to be 0.005, and then the other part of the area over here is going to be 0.005, and we know they're the same because our normal curve is symmetric. All right, let's go to table A3. We're looking for 0.005, and we're going to read down to the z line. 0.005, here it is. It's 4 from the right. We're going to go down to the z line. 1, 2, 3, 4. That gives me 2.576 as my critical value. So let's take this one away. This side is going to be 2.576. And that means, by the magic of symmetry, this side is going to be negative 2.576. And we want to know, down here in part C, now that we found our critical values, do we want to reject the null hypothesis? Well, that all depends. Where is negative 3.248 going to be located? If it's in either one of my purple regions, then yes, we're going to reject our null hypothesis. But if it falls inside here in the white region, we are not going to reject our null hypothesis. And negative 3.248 is going to fall somewhere right in here because it is smaller than negative 2.576. So because my z statistic is in the purple shaded region, we are going to reject the null hypothesis. And we're going to reject that because my z statistic, negative 3.248, is actually less than the critical value, negative 2.576.